Okay.
I'll
All
be
right. I
here.
see.
Yeah, I'll be here on the side. If you need anything.
Okay. Cool. 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 All right. That's not right. Okay. So you can see it. Okay. So we'll be using the Unity game engine for this workshop. So Unity, it's just a free source here. I'll just post here Unity. You search it up. This is going to be the first one that you find. And you can just click on get started and you go on individual and then personal and student, it's all free to go. So it is totally free to do like personal stuff, to do indie game, right? Like you just need revenue or funding less than 100K. So it's perfectly good for a hobby purpose as well. So yeah, so it's a great asset for you, your upcoming game developers to use Unity as your game engines. So when you download Unity, it'll give you Unity Hub. When you open it, you want to click on install, and then you want to find an official release, or like you want to install an editor, and you want to install one of the recommended. I recommend just the 2021 versions and stuff. You can use it 2020. That this is the LTS version, which means it gets a long time or is it, I don't know, lifetime support or long time support, which means they're gonna keep it updating. And this is the stablest version, but I like to use the newest one because it might have something cool feature or like performance fix. So once you install an editor, you can get started by click on projects and create new projects. There is a lot of template you can choose from. Right now, I'm just gonna choose from 3D, and we can work from scratch. And Yeah, so just to get the gist of it. By the way, 3D sample scene, this HDRP and URP you might want to use based on your what you want to do. So HDRP stands for high definition rendering pipeline, which is for like high fidelity games that might be using. So this is a way of rendering, a rendering pipeline, which means how a thing is rendered in general. So HD rendering pipeline just means it renders high definition stuff, if that makes sense. And then URP means universal render pipeline, which I think is pretty good, and you should 90% of the time use this, is because universal rendering pipeline gives you what we call not too much high definition, because you don't want to use high definition in a low poly game, because first of all it will affect the performance. So you want to use universal render pipeline for that, because universal render pipeline you can also customize a lot better, and it's just it gives a medium graphics level, and then you can have the 3D one, which just uses the standard rendering pipeline, which is not that impressive. But I'm not gonna overcomplicate stuff, so I'm gonna use the 3D stuff to start out with. So I can call it XdHacks mini, and then I can create this project. But yeah, so 3D. You can use other templates if you want, like third person, I mean third person, whatever. It will create a lot of stuff for you. But right now, for workshop purpose, I like to do it from scratch, if that makes sense. So yeah, we'll let that load. It takes a bit to create. All right, so as that loading, I'll be going through what I want to cover for this session, I guess. Okay, so the main thing I want to do is to just create a first person shooter game, uh, kind of show you guys how camera system works and whole entire thing like that. I don't want to go in depth since we only have around maximum of an hour ish. So yeah, so this is what you get for empty a whole entire empty scene, which is just the main camera and direction light. When you can press F in the scene to focus up. So this is the scene. So this is what you're gonna build stuff on, and then the game, it's a preview to the game itself. When you click on run and then play. So what happened is you can right click over here. So we want to make a ground first, right? So we're gonna go for a right click 3D object. I like to use plane for just the ground because it's just literally kind of just a plane, right? It's not that computationally expensive to render and stuff, and it's just a good thing to. So position, I just set everything to 0 first. 0 0 0. So right here you can see the transform. The transform component, it's the game object's position, well, specifically I think local position, yeah, of this thing. So transform tells you where this thing is rotation is, the position, as well as the scale. So the plane, we're gonna right click and we're gonna just rename it to ground, for the purpose, right? This is a ground. So lighting, I might not focus too much today, but you know, if it, I mean, it works right now, so I'm not gonna go further onto lighting, which is kind of a complicated subject. But yeah, so what happened is we can just create a little capsule as our kind of player right now, our makeshift player. So we can pour a capsule in, or I'll just 0 0 0 this. And put a little bit off, and you can see this ground's probably too small. So what we can do right now is we can use the I like to use the rect tool. So we can just make this bigger. Actually, we can make this a lot bigger if we want. This big. I think that would be good. And then again, we center this. So now we have our player, which is just a capsule. So we're gonna use this as our player. Obviously, the lighting can go off. Okay. So this is the main camera. The main camera is it's your viewport, it's your eyes. So what you can do right now is in order to you know, get the camera follow you, or like we're doing a first person shooter, so we preferably want the camera like in the player, like so. So what we're gonna do is actually we can just the easiest way is to put the main camera under capsule as like a child component. So now what you can do now is when you put 0 0 in here, it actually centers in the 0 0 of this parent component of the capsule. And then you can make a fine tune of it. We can put it like here. And then for the capsule, we can rename it to player. All right, main camera. There we go. So now in games, this is gonna be the camera just pointing outward from the person. So this is perfectly exactly what you want to do, right? And now what we're gonna do is we're gonna add a little component over here called character controller. There is an alternative to character controller called rigid body that actually uses a lot of physics and stuff, but that takes a lot of setup. So character controller, it's actually what I like to use anyways, just because it's not that much physics involved. So yeah, so the character controller allows you to basically it's yeah, so it's just a controller that like controls like a player object's properties, like going up a ramp, the slope limit of going up a ramp, the step offset, the skim width, etc. So now what we do is we want to introduce gravity first, right? Because gravity is quite important. So what we're gonna do is we can create a new folder here, create folder, one called scripts. So this is where our scripts is gonna go. So where the code is gonna come in. So we can create a new C# script. So this does utilize Unity, does utilize C#. So yeah, so this script, we can call it player movement. So player movement is going to be the script name. We can open it up. So for coding with C# whatever, I like to use this thing called writer. But it does cost money, but for what do you call it, for a student, you can ask them for a free free license. So so this is a writer by JetBrains, so RIDER. I really like it, but most people will probably just go for what is it, VS Code, which is just the Microsoft like a free code editor, and then you can like add components into it, for example C# components and also like Unity components, which you can find tutorials online for. But yeah, so this is just why I like to use. You don't have to use it. So all right, okay, let's get started. So for player movement, so you can see it already creates two things, so start and update. So what start is, it's a function that calls as soon as the game starts, and it calls only once. So it only calls as soon as the game starts, and it won't repeat itself throughout the duration of the game. But update, what it does is right after start, it will go into this update loop. It's kind of like a while true loop, so it goes forever and ever as the game keeps running. It says updates called once per frame, so every frame that you render, it's gonna create call this void update function. So yeah, so that's how it works. And now what we're gonna do is we're gonna introduce gravity. So first, what we want to do is we want to have we're gonna put this under player. So go over here in player, and then we can add components. We can find player movement over here, and then we can add it onto that. So now this script, it's gonna be under this player. So now what we can do is we can go back to here. And then what we can do now is to just reference the character controller. So how we're gonna get the character controller is that since character controller, it's also part of a component of player, what we can do is we can just get a character controller like that. Character controller, we call that CC. It's going to be equal to get component, and then we can find character controller. So this will only work if the script's sibling component is character controller, which exactly it is. So it works this way. There's a chat. If you join, it's fine. Oh, okay. All right, cool. Anyways, so this is just how you reference character controller and stuff. So we can have obviously up here we can say private character controller. Actually, we should do the SCC, and then what we can do is we can do this. So then it will already say you already declared a character controller called CC, and then at the start you're gonna link the reference of the character controller to the character controller of this what do you call it, this player object. Okay, so now once you get the component, what you can do is obviously we want the gravity. So we're gonna have what's called a serialized field. Then we can call it private a float. We can say gravity. So over here in gravity, so what a serialized field does is when we go over here, as it reloads the script, we can go back, we can see that there's going to be a gravity thing that we can input. So, you know, we can input 2 right now. What we can do right now is we go back to serialized field gravity now. This gravity flow is going to be 2. So this is really cool if you want to tweak something that something is not really like set in stone. For example, gravity, maybe you want a lot of gravity, maybe you want a little, we can just tweak it right under the editor, which is super cool. Now, what we can do is we can have a current gravity because gravity, if you learn in physics, it's an acceleration. What we can do is we can also have another serialized field. I can just duplicate this called maximum gravity or the terminal velocity, right? Maximum, we can just say maximum gravity. So this is the maximum gravity velocity you can apply or the terminal velocity. So we can set this as well later on. And yeah, so obviously the maximum gravity, so the gravity acceleration is always going to be 0 at the start. And then as the game gets updated, it's going to subtract the gravity, right? So we can go over here and we can do so gravity, max gravity. Well, max gravity is going to be the maximum gravity, sorry. So we're going to have another one, but this one doesn't have to be a serialized field. We can say current gravity. So this is going to be the gravity that we actually care about, right? So 0 just means it's a flow. So it doesn't matter. So it's just 0, but I like to put the F there because it's a float. So emphasize on that. So yeah, we can have current gravity. So we set that to 0. Never mind. So once an update, current gravity, it's always gonna minus equals. What do you call it? The gravity we have right now. And then the maximum gravity, so we're gonna, yeah, actually we can just do plus equals the gravity. And then we gotta make sure the gravity, it's always gonna be, what do you call, under max gravity. So what we can do is we can actually do current gravity. It's equal to math f dot, so the minimum of gravity plus current gravity plus gravity or it's gonna be max gravity. So what this does is you calculate the next gravity, right? So what minimum function does, it's it makes current gravity or it returns what we call the minimum of these two things, right? So if our max gravity, so if current gravity plus gravity, it's going to exceed max gravity, or it's going to be bigger than max gravity, then we're just going to make max gravity the current gravity. But if, because, you know, maximum gravity is going to be lower than current gravity and gravity combined. But if current gravity and gravity combined, it's going to be less than max gravity, then we're just going to take current gravity plus gravity. So that's going to make sure that at max, it's going to be max gravity and will never go beyond max gravity. That makes sense. So now we have current gravity. What we can do is we can apply gravity, right? So applying gravity, it's just going to be, so we can do, we have the character controller and we can do cc.move. So what move does, is yeah, so it applies the movement of an object. So obviously move, it's gonna have current gravity. So we for movement, because we're in a 3D world, we're gonna use something called vector 3. We can do new vector 3. So this is gonna be X, Y, and Z axis, which you can see in transform over here, position X, Y, and Z. That makes sense. So now we can do is we can have y-axis is going to be where you jump up and down. If that makes sense. So actually, just gotta make sure that is correct. So the blue one, yeah. So yeah, so y, it's, you see how y is changing the value. So y, it's up and down in a 3D world. And go back here, we can have 0 here, but we can have current gravity here, and then we can have 0 again. So now there is one flaw to this, is because you know how we call update, it's called once per frame, but sometimes you can have a lot of frame generated just based on your computer, how good your computer is. So it's not going to be consistent of the gravity. So what we can do here is actually, we can do gravity times something called time dot delta time. So delta time is going to be the last time. So here we can hover it, the interval in seconds from the last frame of to the current one. So what this does is it normalizes. So in 1 second, it's going to apply exactly what the amount of gravity is going to apply. That makes sense. So this is why we're multiplying delta time, because we got to make sure the gravity stays consistent, because, if you, again, learn physics, acceleration, it's meters per second squared, and you want to make time constant and relative, right? So it's every second it's going to have that amount of gravity. So we want to make sure that this time doesn't go out of sync if you if you generate a more, we're now going to generate 1 frame a second. So that's why we're going to multiply time delta time here. So yeah, and gravity should be negative because, it's pulling you down. Sorry about that. So now we can go back here and we can play around with the thing a little. So here we can have gravity of 2 and maximum gravity of 8. And you can just see, play around, right? So this should theoretically move it down. So if we play, yeah, it moved it down, but as you can see, it's a little bit too fast. So we can do is we can do 1 maybe, and we'll see how that works. Go up 1. I'm afraid, that is still a little bit too fast. My likings 0.25, and gravity, max gravity of 5. We'll say. We'll see how this goes. Yeah, okay, that's fine. That's fine. Yeah, okay. So when it's hitting the ground, it still has the gravity of, that amount, right? So when you are heading in the ground, you want to make sure that when you're on the ground, it doesn't, the gravity goes back to 0. Current gravity goes back to 0, right? So what we can do here is we can have a function that checks whether you're on the ground or not. So we can do a Boolean function, a bool, that returns true or false. We can actually call it a private function, private bool. You don't really have to know what private and public means. You can, so private bool, and we can say it's grounded, or it's grounded, right? So we can have that private bool is grounded. That's going to be our function. We can do here is we can just return. So what I like to use for checking ground is I like to use something called physics.checkSphere. So sphere, so this is return any like so what it does, it's gonna make a sphere at a place like kind of how do I put this? So it makes a sphere at whatever location you chooses. And it makes this virtual sphere, and then if this sphere hits anything, it's gonna return true. So that's basically what check sphere is. Basically, it projects a sphere, but you can't see it. But if there's something that you detect a collision of, it's gonna return true. So basically, if you're in the air, you want to make sure that the way to check if you're in air or not is that if this sphere doesn't detect, or like this sphere you cast doesn't like contain the ground element to it, then you know that you're in air. But if it, is the ground element, it's inside the sphere, then you know that you're on the ground. So yeah, so let's implement this. So we can use something called position. Transformer. It's called transform dot position. So this is the current position of where you're at. So preferably you want to check the sphere at your kind of your feet, right, of the person. So we can see here is that the person is actually centered. The 0, 0 of this person, it's actually in the middle. So if we want the ground like this feet level, we actually want to know the local position of over here. So we know something about this capsule. The height is 2. So what this means is that this is going to be a -1 position right at the ground, because this is right in the middle, and that's 0, 0. If the height is 2, that means half of the height, it's going to be 1. So it's going to be at -1. It's going to be at the ground. So we can do here, we can go back here, we can do minus and vector 3 down. Well, just plus a vector 3 down. So what a vector 3 down is, it's a short form of a new vector of 0, -1, 0. So when you add vector, you just add x and x component, y and y component, and z component. It's nothing really, too scientific about that. So this is going to be adding a -1, which is actually exactly our height. So we don't really have to multiply to scale it. So now what we can do here is, this is our position. What we're going to do is we're going to have what we call the sphere's diameter, if that makes sense. So again, so radius, sorry, it's not diameter, radius. So radius, we can just do 0.1 f. Again, it's something that we can tweak. So we can actually go over here and we can set a ground height. So this ground buffer. So this is how much leeway you want to give for the sphere, right? For you to check if it's grounded. So we can move that around, and then we can have a layer mask. So a layer mask is so we can call it ground mask. Over here, so it's gonna be on reference first of all. Ground mask. It's gonna be called layer mask. So what a layer mask is obviously sometimes you want to check sphere. You don't want to check like if any objects in there. For example, if we're gonna check it's grounded, we're mainly focusing about ground object, planes that you can walk on, right? You don't want to check a player if you're like kind of if you're on top of like kind of fire element or whatever, like something that you don't wish to stand up on, and you don't want to make sure you don't want to say it's grounded, because that object, it's like technically you are sensing something underneath you, but that's not ground. So like obviously you don't want to say it's grounded, right? So what we can do is we can actually kind of filter it out, filter the stuff that you don't want by just saying like what you want to detect. So for ground mask, we just want to detect ground objects. So going over here, so you can create a layer mask by going over here and you can say layer. So we're going to add a new layer. We're going to call this, so we can just go layer 3 and we can call it ground. Or just, I guess, standable. No, we can just call it ground. This is just, we don't want to overcomplicate things. Call it ground, and that's it. So if it's in the ground, we can add it to the ground. Yes, change everything to children. Oh, it's like, actually, this doesn't matter. We just want to make sure that this is ground. Not actually, player is not ground. Sorry, the ground is ground. Sorry, that's my bad. So yeah, so if it's ground, so the ground layer is set to only, the ground itself. So what happened is that the check sphere collision is going to only check the ground. So now we have that set up. We want to make sure that we select this ground layer, right? So going over here, so a cool thing about the editor is that you can select. So we only want to check ground. So yeah, ground is checked. And you can, I think you can check multiple. Yeah, you can check multiple, but we're only going to focus on ground for this one. And ground buffer, we're going to set it to 0.1. So now this should technically work. You check is grounded. So what we can do now is actually, we can just, we can do a debug.log. So log. We can check its grounded. So what this does, it's gonna go over here in the console section. Actually, this is important. So in the console section over here, you can see there's a console. So what debug.log is, it's gonna print out whatever you want to print under the console. So right now we want to print if it's grounded, it's true or false. Just make sure that it works. So let's try it. Oh, sorry. Grounded. Oh, yeah, it's not reloading script. Sorry about that. Okay, so now you gotta make sure, yeah, false, 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 and then true. And now true is gonna be all the way, and it's gonna be called a lot of times because, it updates every frame. So you can see it works. When you're in the air, it says false, and then when you're on the ground, it says true. So hooray, it works. So this is grounded function actually works pretty relatively well. What we can do now is we can implement this to our gravity. So we want to say we only apply the gravity. So if, it's grounded, if it's grounded, so if grounded it's equal true, that means current gravity is going to be equal to 0, right? But if it's not, right, else, then we're going to apply gravity. Then obviously we can just move cc.move because, if it's grounded, then there's no point of just. So we can just still like apply the move function here. Won't affect anything. So now we can stop debug.log because we know it works. And now we can, I'm gonna make this reload. Okay. So now it shouldn't, so it should reset this thing. So this thing is gonna act more like physics object. No? Yeah. Okay, see, now it's not like, yeah, see, now the velocity is actually going down and all the way down. It doesn't hold the velocity, which we don't want. So this is working as intended. So that's good. It's working just like gravity, how it works in real life, right? So this is good. Now, you know, when gravity is applied, obviously, we can do like some other cool stuff with it, I guess. I guess we can, yeah, well, we'll make so movement now, obviously. So movement we can do is actually they have a very convenient function for movement, which is actually just so input. Here, can I find? So if it's a first person, we can just do I can do I'm just gonna make sure this is input.get. Yeah, axis. We're gonna have horizontal. So this is all set up for us. So we're gonna say float. So horizontal, I think it's up and down, right? A and S. Just want to make sure. So forward and back. And then we can have left and right. Be vertical. Okay. I think left and right it's horizontal here, forward back. Okay, we're gonna test this out by pressing WSD key, obviously, so we can have a debug dialog again over here, and we can have forward, backward, and then so now we go back and we test this out. Right? Oh, sorry. So here. So it's 0, 0. See, when I press A key, it's gonna go to left. -1. When I press D key right now, it's gonna go +1. W key, +1. And then S key, -1. So you see, this it's working as intended. And right now I'm not holding in any key. It's gonna go back to 0, 0. So this is working pretty well, relatively. So left and right it's as where it's at as well, forward and backward. So when I press A and D key, left and right is changing. So we know that left and right is indeed horizontal, and then forward backward it's indeed vertical. So we've got that down. Now we can just implement it, the movement. So because we're gonna add like all these things together, what we can do now is we can have just a standalone vector3 function. Is going to be called the velocity. So this is going to be the velocity of this player at the start. So at the start, we can set the velocity equals vector 3.0. So it's just vector 3 is just dot 0, it's just 0, 0, 0. So we set that as equals 0, 0, 0 first. So now what we can do is when we apply gravity, we can just add this new vector. Okay, so we can over here, when we use gravity in the velocity, we're going to add current gravity. So we're going to add vector 3 dot down because, you know, gravity, it's a downward force, and then we can multiply by current gravity. So what this does is so when you multiply a vector 3, it multiplies x and y and z all with this scalar called current gravity. So we know that vector 3 dot down is 0, -1, 0. So what this does, it's going to be when you multiply by current gravity, it's going to be 0, and then the negative current gravity, and then 0. So we want to add that into our velocity because that's going to contribute to our overall velocity. Since, you know, we can actually pull this out here. But yeah, so velocity is gonna be 0 every time. We're gonna set velocity actually to 0 every single time. Starts. And then we can do velocity add current gravity here, and then just set the move function actually just to velocity, like so. So now it's gonna move with the velocity that we are given him. Alrighty. Now in here, you can set walking speed. So another flow, and we can set speed. So speed is going to be how fast you walk, whatever, right? So we can do here is we can have the velocity plus equals so left and right, right? So it's going to be right, vector 3 dot right times. If I just want to make sure this is yeah, the right motion actually. Yeah. So we can actually say vector 3 dot right because move is actually on a global scale. So what happened is that it's not so when you're facing forward, based on the rotation, it might not be, it might not go forward all the way because, when you're rotated, you want to make sure that you're pointing. So there's something called, so if you're going left and right, you can do transform dot right. So what this does is it actually tells you, what do you call, the vector of actually going right. So you know how the world we're at, where right is actually just on the x-axis. So yeah, so when you hover here, it says is the red axis of the transform in world space. So yeah, so this is going to change our local position essentially to a global position to the world position we're at. So since cc.move is a function relative to world position, we'll make sure that when the character is going right, it's not going to the global right. That makes sense. I know it's kind of hard to explain, but when you're rotated in a way, when you go to the right, it's not gonna be -1 on the x-axis all the time, right? So transform that right, and then we're gonna multiply by left and right. So LR, and then velocity plus equals transform the forward times forward and backward. So yeah. There we go. So right now, theoretically, this should work. So we're gonna test it out again. We don't have to multiply time.delta time to input.getAccess because input.getAccess is already independent from update, if I remember correctly. So it doesn't affect, just make sure it compiles. Okay, I think it's compiled. Can try this forward. Oh my God, that's too fast actually. Oh, right, we have to, sorry, my bad. I have to multiply by the speed scalar as well. Sorry, almost forgot about that. So, speed scalar is where we're gonna set the speed of how fast we walk. So we're gonna make sure it's not gonna go zoom. All right, this character is not a car, right? So we're a spaceship. Can do at 0.5 or 0.2, I think will work lovely here. I gotta make sure 0.2 works. Actually, all right. So backward, yeah, it's still too fast in my opinion. Oh yeah, sorry. Actually, for going left and right, up and down, we really want to make the speed time.delta time. Sorry. Yeah, because the speed is actually going to be meters per second, right? So we want to make it consistent. Sorry about that. We're going to multiply by time.delta time for the speed. So now we go back, sorry. That up. If I multiply by speed, yeah, it's not as fast anymore. It's still moving, right? Set on the side. Yeah, see, now it's moving 0.2 a second. So now we can actually change this to make it fast. Well, I actually think 1, maybe 2 is good. Sorry. So now with 2 as the speed, yeah, see how it's moving forward right now. So I'm pressing my W key. So it's moving forward, and my A key is going left. Go right for the D key, and S key is going to go back. See how this little capsule moves? So that's cool. Now we're going to get into rotation of the character. So rotation, we can just have float. Again, float, but this doesn't have to be serializable actually. So we're going to put it down here, and we can call it camera. So cam, we can say cam, the yaw of cam, right? Camera. Obviously, it starts off with 0, and then float cam, the pitch, right? Pitch is gonna be the up and down motion, right? The up and down, what we call rotation, and then yaw is gonna be left and right. So pitch is gonna be 0 as well. What we can do now is obviously we're gonna have to reference our player, right? So, oh yeah. Okay, so we can do is we can rotate based on like the movement. So actually what we want to do is we want to update, want to make sure that the camera is going to move. So we can do is camera pitch or camera yaw dot plus equals. All right, so there is something called input dot get axis mouse x, because mouse x is going to be horizontal movement, which is exactly the cam yaw is, and then the pitch we can do mouse y. And I think this is good. I'm just gonna make sure this is good. Sorry, I'm just gonna reference this. So yeah, okay. And also we can have something called mouse sensitivity, right? So float again, and we can have something called the sensitivity, sense. So this is gonna be the mouse sensitivity of your camera over here. So mouse sensitivity, obviously what you can do right now is to just go over here. And actually we create a function here called rotate body. Create a new function here called private void rotate body, because when you go X and Y, you're actually just rotating the body. And then when you do the pitch, that's when you rotate the camera. That makes sense. So when you swing your we call mouse left and right, you're actually rotating the body itself, right? If you played any FPS game, you know that like when you go left and right with the mouse, the player moves his body left and right as well. And then when you go up and down, like games like Valorant, CS:GO, whatever, Overwatch, the gun actually goes up and down, right? So the camera moves up and down, but then the player actually itself moves left and right. That makes sense. Rotates left and right, or I should say. So we can have, so when we rotate body, obviously it's about a yaw. So we can go over here, and then what we can do is we have this camera yaw and then the body facing. So as I look up, it's actually minus equal. If you do plus equal, you're actually inverting everything. So if you move left, it's gonna move right. So we're not gonna invert it. And make sure that camera y'all, it's gonna be equal to math app. But, I think repeat. Yeah, okay. And then we can have cam and also 360. So what this does, what repeat does, it's if you go beyond 360, it's gonna go to 0 again. So if you have kind of like 361, what it does is it goes to 1. So we just make sure the maximum is 360 and repeats like so. If you hover it, you can see, yeah, never smaller than 0. So it loops the value. Okay. And it makes sense because if you rotate 360 degrees, 720 degree is actually just 360 degree. So it's gonna end up to 0 again. So now transform the rotation. So we're gonna set this rotation. It's gonna be equal to quaternion dot Euler. So quaternion dot Euler just transforms a quaternion angle to a Euler from an Euler angle to a quaternion angle. So an Euler angle it's just your 90 degrees x and y and z, and quaternion is something else, and you don't have to worry about it because honestly I don't even know. Well, I know that it's good practice to use quaternion dot Euler, so that's always recommended. So this is going to change the rotation to quaternion. So we can try this out now, technically. Okay. So this should give us the mouse movement x and y. Wait a second. Oh, yeah, we didn't call rotate body, that's why. So we gotta rotate the body. So I like to do at the very start, we say rotate body. And also we want to put the cursor, make sure the cursor is locked on the screen and stuff. So what we have to do is at the start, we're gonna have to make sure that everything is locked to its place, right? We don't want any like cursor visibility. Visible equals false. So we don't want to see the cursor, and also we want to lock the cursor, right? Cursor dot lock state equal to cursor mode, lock mode dot lock. So now the cursor won't move, won't move outside the screen. Now with this, all we can do is this way. Okay. I'll make sure that this actually moves. Oh, all right. Forgot to apply the sensitivity. So it's multiplying by 0, so it's not going to move a single bit. About that, now it's going to move. See how the camera is moving as you're rotating. So this is working as intended. And then when you press W, it's going to that direction. Press W again, see how it's going around, which is perfect. Exactly what you want to do. Going forward, going backward. So this is super good. Yeah. And then when you go to left, it actually goes to the left relative to the player, not to the actual world left, right? The world left, it's gonna be the axis over here, and you know it's not the player's axis of left and right. Yeah. So yeah, that works. And so we have 5 minutes left. Okay, you know what? We can cram this in. Just to for the fun of it, we can do some jumping too. Okay. So what we can do is we can apply a jump, right? So jump. obviously we're gonna have a private float, we can have a jump velocity, we call it jump vel. So that's the velocity of jumping, right? What we can do is so what jump here does is if it's grounded, it's gonna be at 0, but else. So if we can go over here and we can check if if jump if grounded. Okay, first of all, it has to be grounded so you can jump. You jump when you are on the ground. You can only jump when you're on the ground, right? If that makes sense. So if input dot get so get key, we can do get key down, or we can just do actually we can just do get key. So what get key does, it returns true while user hold down the key by defining key code. Yeah, okay. We want to get key press if there is. Yeah, get mouse button. Yeah, I think this is it. Get key. And then we can do key code dot space. So when you press the space key, what it does, it's, you know, obviously it's gonna apply the thing, right? Get key, and then we can do jump. So what jump is basically gonna be, it's gonna be curve gravity minus equals jump velocity. So that way the gravity is 0 right now, but right now we're gonna apply the jump velocity. Then the current gravity is gonna obviously gonna change. So now we can do go down here. We're gonna apply this real quick. Do here jump velocity. It's gonna be try 2. I'm gonna try 2. See how this goes. Okay, that's, yeah, that's a little bit too much jumping. Maybe we set this not to outer space. 0.25. How about that? Hey, there we go. I think that's good. But also that's still a little bit too much jumping velocity, I think. Yeah, okay, that's cool. You know, that's fun. Hey. But yeah. Yeah, that's super fun. So jumping velocity works. Can do is actually do get key down. So what get key downs is the returns the only frame, the one frame that when you press the key down, and then it will never return true again. So this is actually better for jumping. Yeah, see. And yeah, that's cool. So it bounces, jumps up and down. Obviously, you can tweak the jumping thing a little bit more. I mean, like 0.25 might be a little bit too much as well. 0.1 might just be right. Yeah, 0.1 works. Go up and down. No. So this is going to be the movement of the character done, basically. You get jumping, you get moving around left and right, up and down, you know, in the 3D world as well, which is super cool. You know, an upgrade to your Pi game experience, whatever. You can see how fast it is, or like, you know, if I'm talking, just how little line it is to actually make something that moves, you know, that like that's just basic first person, obviously set up as well. So this is how fast actually you can make. Obviously, we didn't actually do the pitch up and down. Actually, Raf, is it possible for me to actually talk about like the pitch of the camera as well? Do we have time for that, or chat? Sorry. Hi, Raf, you there? Okay,
Yeah, I'm here. How's it going
okay.
there?
Can I extend it a little bit, like 5 minutes, just talk
Yeah,
about
for sure. Take your
the
time.
camp?
Take your time.
Okay, all right, okay. Okay, thank Raf, we've granted time for the camera up and down. So camera up and down, when you go up and down, so that's gonna be, the camera pitch, right? That we set up here that we never use. So we can do is we can do private void. We can do a pitch. We can do a pitch cam. So pitch cam. With this, what we're gonna do with this is we're actually just literally doing the same, like kind of same thing, basically. So obviously we don't want to get the transform of the player again. Again, back when I said we want to move up and down of the actual camera itself. So what we're gonna do is we have to grab the camera, a reference of the camera. So what's cool about Unity is actually this is actually a big part I want to talk about is you can have private, we can have private transform. This is what powerful about Unity. We can have camera, cam transform. So something powerful about Unity is that what you can do here is, again, I need to make it so that it compiles the script. What you can do here is you can have cam transform. Again, non-transform, you want to transform, you can just drag whatever object you want from your hierarchy into here. So then, it's going to reference main camera transport, which is super cool. Taking a sip of my coffee right now. So yeah, so that's how you reference to a home target camera, just like that. So you can see how powerful Unity is. You can put any component down, and then you can drag any component of any object into that that section, that serialized field that you want to use. So right now we grab the transform of the camera. So what we can do now is with this, we can just make the camera dot transform dot rotation of the camera. Okay, first of all, we want to do the same thing we do to the pitch, right? So camera pitch, so minus input dot y now on the y side, and then the same sensitivity. And for the pitch itself, what we want to have for the pitch, it's going to be equal to something called mathf dot clamp. So what clamp does, it's you're given a value. So right now it's cam pitch, and then the minimum value of that value and the maximum of that value. So cam dot pitch is going to be our value, but the minimum value is going to be negative 90 degree, right? Because negative 90 is going to be you looking at the ground, and then positive 90 degree is going to be you looking up on the sky, and you don't want to look all the way back. You don't want to go launch backward more than like you look up the sky. That would be weird. That means your head is actually just rotating around freely, which is not what a normal human being does. Your head doesn't just spins like a wheel. So we gotta clamp that down. So then we can do is same thing, same exact thing. That's this. Now we're gonna have the clamp camera pitch. So for this one, it's gonna be on the y-axis. So because the y-axis, it's gonna be going through here and it's gonna drop also. The x-axis is the one that's gonna rotate the head, if I remember correctly. I don't want to say I'm 100% sure, but it's either X or Z, but I think it's X. So I'm going to try that. So yeah, now let's try it. Make sure everything works. Pitch cam. Obviously, we got to call the function real quick. Okay. Pause. Cool. Yeah, when you look up, look down. There we go. And you can maximum look up and maximum look down. Again, see, this is what clamp does. It clamps your thing to make sure that it goes only the lowest you can go is -90. The highest you can do is +90. But yeah, you can move left and right, up and down, you know, the whole entire thing. And this is basically free moving camera. And you know, like this is the backbone of what every, you know, first person FPS is. I couldn't have time to, like, you know, cover animation stuff. That would be like too much, I think. But this is should be a basic setup of how you can make a first person game, and just make sure that, you know, you understood. Obviously, again, you jumped too high up. Forgot. I set this to 0.1. Sorry. But yeah, so when you do that, you just get a basic game actually, and then you can, you know, do whatever you want from here. But yeah, thank you. This is I think this is a good place to end it. But yeah, hopefully you enjoyed the workshop. Hopefully you make, you know, you understood what I'm talking about and everything. Again, it's about experience. You gotta, you know, get out and play around with these things. You learn a lot of physics too. So again, XdHacks, it's about cross-disciplinary. You can see how game development actually makes you understand what velocity is, what you know, speed, how just the real world interact itself. So it's really good if you want to go into physics field as well for game development. So you can see how game development come to help in physics and stuff, a lot of stuff like that, which is, you know, super cool. I think you're gonna, you know, if you like physics, then you should definitely dab a little bit into you know, these kind of game development, do some little simulation, physics simulation, perhaps. Do some research on how flying works. You know, you can make a flying simulator as well. Like, it's just you know, it has so much physics in it, and a lot of math as well. Vector math, I talk about that. Vector 3, what a vector is, you will learn in grade 12 in Canada, right? So there's a lot of cross-disciplinary here in game development, and I think it's really useful. Yeah, so if you like math, if you like physics, definitely try this out, and just make sure just to see how, like, you know, coding, it's not just solving a problem. It can be something that's you know, you can use to create, and that's where I love computer science and programming in general, is to create stuff and to simulate your world and understand your world better. So yeah, thank you.
Thank you, Eston, for the wonderful workshop. Just one question.
Yeah,
What
sure.
would you recommend other people do if they want to learn more about game development?
So what do I like, what do you mean by that? Like
Like, what do you recommend them learn after this workshop?
well, after this workshop, obviously I want them to, you know, make a game. Actually, just go out and make a game. I've set up the basic of how to move around in a, you know, in FPS game, right? So just go out there, try and do research how to make an FPS game, make a simple FPS game. It doesn't have to be like all flashy, whatever. You don't even need to have like a player model. You can just have like a bunch of capsules fighting each other, and that'll be fine. That'll be fine. That's where I should start. But like obviously I think making a game is one direction you can go. Another direction you can go is actually go and learn about how to apply animation. So I think animation will be cool. I think that's another way where you can go, because animation, you learn about like movements and stuff. It just adds flares to your game, and also animation is kind of a big thing in gaming in general. So I think that'll be a good place to start. And Unity has a good management system for animation. So So I guess my two suggestion is either learn about animation, character animation or something like. Actually, I'll link a website too. It's called Mixamo. Here so what Mixamo is, it's where you can get like free animations and free characters, just straight from this thing, and you can have animations, zombies stand up. These are all free animation you can download. Just create an account for free and just download everything. And this is a good place to get your animation from, called Mixamo, Mixamo. So Mixamo. That's a great place. So yeah. So again, to reiterate, make a first person game, expand on this to make a full game, or just to learn about animation. I think those are the two ways that you can go the next step of game development. So yeah, hopefully that answers your question, Raph.
Yep, that answers the question pretty well. Thank you, Aston. And the video would be posted on YouTube if anyone misses the workshop. And yeah, thank you guys for attending and hosting the workshop. And I'm gonna end the meeting now. So have a
Okay,
good day,
cool.
guys.
Yeah, thank you for having me. Goodbye.